All right. I'm gonna discuss about in this video. I'm gonna discuss about the compounding and effective modification. This is one of the most confusing topic in biostatistics or epidemiology. Okay, so very confusing the between two, and then very also important in terms of the bias, and then also very frequently asked in the USMLE and the CAS questions. So I'm gonna explain it in probably the very understandable manner, so you don't get confused. Okay. Okay. Probably the best way to explain this is in terms of the examples. Okay. So, for instance, look at this example here. Uh, there's like the hypothesis that okay, big shoe size has a higher IQ. It's a little bit mysterious, right? How come? What does the big shoe size has to do with the IQ? It's very strange. Now, if you look at this carefully, um, younger kids has a small shoes, and then the bigger kids has the larger shoes, right? So young kids it naturally have some impact in the shoe size, right? The younger, the smaller shoe, and then also the older, I mean younger, the kind of low IQ. IQ is not really like clear term, but it's a correct term. I think it's kind of intellectual ability to solve the questions or something like that. Okay, so like mathematical ability, something like that. So you can just modify that. Understand this as a like a little bit the different terminology. Okay. Anyway, so younger people, younger kids has like less ability to solve the questions, whereas older people the have a better ability to solve the questions. But if you look at only the shoe size and IQ, it will and then if you plot it, and then if you do some analysis, then it will be like this. So meaning that the shoe size is a shoe size as the shoe size increases, IQ increases. But is it really the case? This is called the confounding variable, confounding bias. What that means is that actually this is not shoe size. This really the problem was age, because age is associated with the shoe size, and then also age or associated both also the intellectual ability. So what happens is if we the way you find out whether this is a confounding variable or there's a similar term called the effective modification. Okay, so whether it's the confounding or effective modification, I will explain what effective modification later. It's you have to stratify. What stratified means is that um, if you have a like this the confounding variable, age. Age is called confounding variable. Okay, so confounding means like which is a kind of con means that both related to this, and then the both shoe size and IQ both it has the relationship association, and it is founding. It is basically hidden in terms of this analysis. It's not directly shoe size and then IQ, but it's hidden variables. So the way you the stratified is that you basically you look at the separate this the two groups, say shoe size and IQ, right? But you have you are the thinking that okay, maybe this is not really because of the shoe size and IQ, but maybe because of the age. The way you to overcome this or reduce the this bias is that differentiated with the stratified. Sometimes it's called matching. Okay, it's same thing. Is it matching? So matching by age, for instance, in this case. So match age means that you have a younger age, older age, right? Younger age people, so young age people, and then older age people, and you separate it out, and then young group, older group separate, and then you do the shoe size. So shoe size is if there's any other relationship between shoe size and then IQ for each group, older group, younger group. You do the analysis, then you will find that there's no really association in both groups. Okay, so if you look at the diagram, it plot it, and then the shoe size in here, maybe this is a young age, this is maybe old age. Okay, so among these people, shoe size and IQ is not really the related. It's just a random. Do you see that? And then also in this group here, older people, shoe size and IQ is not really related. Okay, so what we are really the was confused, was misled from at the very beginning analysis, which is correct crude analysis, which is non-matched analysis or non-stratified analysis by age. Okay, and in this case, we were thinking that, okay, shoe size has something to do with IQ, but we separated out, we match it by the confounding variable, whether the old age, younger age. So if we think that, if we suspect age is the problem, then we separate out with by the age match the age. So old age, younger age, and we separate separately to the analysis. Then you will find that there's no relationship between the IQ and shoe size here. If you look at, for instance, if you look at this separately here, for young age, then you will see it's like this, right? Is there any relationship here? No, right? Shoe size and then the IQ. There's no relationship. For old age, same thing. It's like this, right? This page, it's like this, right? So there's no association between, no relationship between the shoe size and then IQ. Okay, so if this is happening, so basically, in other words, if you separate out these two groups by the age, by the confounding variables, by matching. Okay, so this is called, sometimes called matching, or sometimes called stratification. Okay, so another example is in our this example here. Basically, they are looking at the alcohol and the blood cancer. If we know some kind of background in the medicine, you will see, we know kind of the bladder cancer has to do with the smoking, right? Now, very similar thing occurs in here: alcohol and the bladder cancer, right? Bladder cancer. Now we are looking at this the association. And then we do the analysis, and then the risk, relative risk is at 1.81, which means that relative risk is greater than 1, means it's very associated, meaning that the alcohol consumption has about 1.8 times higher risk of higher chance of getting the blood cancer than non-alcohol people. Okay, and also p-value is 0.03, means that it is significantly significant. That means that it is like the I think I hope you remember the positive and the negative for H0, then H1. If you don't know this, understand this, my this thing here. then just look at what's the hypothesis testing video, which explain what I meant. Okay, so this basically is the risk rate, a relative risk of the one greater than one means that there's like a high chance of the alcohol consumption is related to the bladder cancer. Okay, so positive relationship. In other words, H1 is not same. Okay? Alcohol or no alcohol is no difference. That's the null hypothesis. But here is a null hypothesis. We just reject the null hypothesis. Is basically positive relationship. Okay. Now, so the way we do here is that okay, we suspect that the question says that smoking, and so we do the like matching the basically smokers and non-smokers. Okay, and then we do the if there's any relationship, similar way as the age in terms of age, young age, old age, right? We do the like same thing for smokers and non-smokers. So among the alcohol users, we divide into the separate into the two groups: smoker group, non-smoker group. And then we do if there's any relationship between the alcohol and the blood cancer. We do the smokers group, the alcohol and blood cancer relationship turns out to be a relative risk is close to 1.95, right? And p-value is very high. What does that mean? P-value is very high means, which means that the alcohol and the blood cancer, the if this is high, that means H0 and then H1, right? This is a negative, and then this is positive, right? So basically, if this is high, that means that we don't take the H0. I mean, we don't take we don't take the high H1. We take the if this is high, this means that the positive is not true. So meaning that H0, null hypothesis is true. Okay, so p-value is high means that the positive is rejected. So we don't take the this null hypothesis. I mean the alternative hypothesis. We take the H0 null hypothesis. Okay, so same thing in here. P-value is high, and then relative risk is the 1.03. So means one basically these two cases both we think that okay, there's no additional risk of the alcohol consumption, and then so that means that whether you drink it or the not drink it doesn't make any difference in terms of blood cancer possibility. Okay, so we in both cases because the p-value is high, and then the relative risk is close to 1. We just don't take the alternative hypothesis. So it's not positive, it's just negative. There's no difference. So basically, this information and then this information are basically almost kind of same thing, just duplication. Okay, so now that's the I hope you understand the confounding variable. Now what's the difference between the effect modification? Let's just do before you go over that. Let's just do just one more example, just graphically. There's also the coffee and coffee and what else? I think coffee and there was one. Let's see, the cardiovascular disease, and this is related to smoking, I think. Yeah, in this case also to study the like coffee and then the relationship between cardiovascular disease, but there was like smokers and non-smokers. But the problem is the coffee is not related to the cardiovascular disease, but the coffee among coffees. So there's some smoker, and then the smoker because when you drink coffee, you also drink, you also smoke. Then also there's a relationship between smoker and then the cardiovascular disease. So something this in order to have the confounding variable, this confounding variable has confounding bias. I mean, confounding variable has to do with the associated both the the falsely the relationship, false association. Okay, this is false. So between this independent and dependent variables with falsely associated, and this the smoker or the confounding variable has to be both associated in both the independent and then dependent variables. Okay, understanding this is very, very important. It has to be associated both. Okay, so in this case, alcohol, the alcohol and the alcohol and the bladder cancer, right? So smoking is related to the alcohol because when you drink, you smoke too. And then smoking is related to bladder cancer. Okay, in only if these two conditions are met, this and then this very, very important. Both has to be related to the confounding variable. Then uh, you can solve the mystery that why that the alcohol is related, why alcohol is falsely related to the blood cancer. Okay, false related. This is important. False, and then this is the true, true. Okay? Truly associated, smoking and alcohol truly associated. The smoking and blood cancer truly associated. Where here again, age and shoe size truly related, and then age and IQ truly related. But whereas shoe size and alcohol falsely related. Here, where is it? Yeah, here, falsely related. Alcohol and the blood cancer falsely related. Okay, so there's another very similar term called effect modification. What this means is that effect modification is not falsely related. It is when there's some truly related the variables. Uh, for instance, in here, aspirin, and then the Rye syndrome. Okay, let me just throw this here. Aspirin here, aspirin here, and then Reye syndrome, right? You know what Reye syndrome is for aspirin kind of intoxicity, right? Now we are looking at this. Now that okay, whether this is really related to if there's any true relationship or false relationship. So if there's a true relationship, then the way we can find out is this, whether this is a true or false, right? That's what we want to find out. Now we know that age, young age, has something to do with the race, right? So this occurs only in the young ages people, right? So we divide into young and old, okay? And then aspirin and the race, and then aspirin, race, okay? So if we find out this aspirin has something to do with the race, if this was like the relative ratio is very high, say 2, and p-value was like 0.05, something like that, okay? P is this is p, this p-value is kind of the irrelevant here because I duplicate it because the relative risk is greater than 1. Is meaning that there's a strong relationship, right? So p-value is kind of duplicate because the p-value simply means that p is low, 0. Say less than 0.5, then we will accept we will accept the p1. I mean h1, meaning that the alternative hypothesis is true, right? So that's what this means. So say this was is like 0.03, for instance, okay? So then this information and this information are basically same thing, telling the same thing. Okay. Anyway, so if we do this in confounding cases, if we do that, what's going to happen is in confounding cases, in alcohol and blood cancer cases, right? So then in this case, if we do confounding variables in whether smoking or non-smoking, here like this, then it was a high here. It was a relative risk is very high in alcohol and the blood directly, right? So then if we do the stratified divide by the separate the group smoking and non-smoking, then relative risk is there's no relative risk in both groups. Then the in that case, then we can see this is the age. I mean, the smoker was the confounding variable, right? Now, if we do this in the effect modification, right? So in that case, what's going to happen is that if we do the young age, right, young group, and then aspirin and the race relative risk will be high, very high too. Relative risk is the same or around same too, and then p-value equals to 0.3. Okay, 0.3. So about about same the risk as the we the examine without stratifying, without matching. Okay, then for the old people, it's going to be there's no difference. So for instance, in the age modification, right? Age modifies the effect. So in other words, um, so like here you will see you will see here because old people don't have a Ray's syndrome, right? So this will be just the relatively circle. It's just a 1, maybe. P equals very high, say 0.8. Okay? So old people like this, and then young people like this. And then there's if you just don't combine them together, the relative risk is high. So relative risk high, relative is high, but relative risk is low. That means that if this was equal, relative risk is the same. The relative risk young, relative risk the old are same. Then means and then also this was a relative risk combined is much higher than this. Then yeah, if this was higher than this and this, then we can say this was confounding. But if this is not the case, like this, then so relative risk combined, then relative risk the young, relative risk the old is about same here, right? Then this is the effect modification. Effect modification. Okay, so what that means is that aspirin is related to Ray's syndrome. Also, at the same time, age, young age, also related to the Ray's syndrome, but young age has a modified. Age is a modification. Age will modify the chance of the getting the Ray's or not age. Okay, so age in this case is effective, the effector which can modify the relationship. Okay, but whereas in here, confounding variables, the what is it? The smoking is not directly. I mean, the alcohol is not directly the related to the blood cancer, but rather the smoking is the confounding variable that is that actually is the hidden variables. So this is called confounding bias. And then whereas this is effect of modification is not really bias. It's just basically the another hidden variable. Okay, another hidden variable that actually has an effect. But in this case, alcohol doesn't have any effect in uh, the the blood cancer. And then the way you differentiate it is you match by the age group, for instance, like here, here, age group, or the confounding variables, depending on the confounding variables, the match with the smokers group, non-smokers group, and then do the separate analysis, and then you will see that the relative risk is very different. Here is a 2, very high related, it's not related. Okay, so alcohol is not related to the blood cancer. That's, in that case, smoking is the confounding variable. Okay. So here, if it is the say for instance in here, the this is the effect of modification. In that case, the age is another the modifier of the relationship. Okay. So age is not confounding variable. And then the way you distinguish between these two is you stratify. So in other words, you match the young age group, old age group, and then do the analysis. And then if it's related, it's still related. This is relatively risk is 2 in the combined model. And then in the young age group, relatively is still 2. That means it's related, right? So both of them are in both cases, the aspirin is related to Ray's syndrome. Then this is not the age is not the confounding variable, whether it's the effector modification. So modify effector that modifies the relationship. Okay, so I hope you understand this clearly. Right. So we'll see the next video.